Hello together. This video explains you how you can use the and validation functionality of the API IO Link Master and how you can change parameters of an IO Link device during operation. First of all, you see here our system. Here is the S7 PLC and the API system. Everything is green, everything is running. If I go in the device view of the API system, then you recognize at the moment I have no port activated, means all IO-Link ports are deactivated. In my real system, I have connected to the first port here a sensor, a pressure sensor of Festo. You see it here. And to make the port running, first of all, I have to define the parameters. I know if I'm looking in the manual, the sensor has 2 byte input parameters. And if I'm going here now to the first port, here you see the first port, I can take here a sub entry with 2 byte for the first port. So taking the sub entry to the first port, I am getting the possibility to parameterize the port. And what you are seeing here, we have here different parameters for the port, and per default we have here the auto start mode. That means we don't care what IO-Link device you have connected, and we just check the process data. If we want to change this, then we make here set port configuration. Now we have here the possibility with validation and backup to define what kind of IO-Link device is connected. We say here type compatible with device version 1.0, means if there is a 1.0 device, then the port is running without any error. The same here for 1.1. And here we have the possibility to generate a backup and a restore functionality for this port. That means we offer the IO Link Master on port 1 the possibility to save parameters permanently inside the master. And we are able to generate this backup functionality. The same without backup, just restore. If I'm taking this backup and restore, then the next thing is I have to define the vendor ID and the device ID. The vendor ID and the device ID is mentioned in the manual of the sensor. And you see here in my case, the vendor ID is 333. And if I'm looking on the type label of the sensor, then I'm recognizing I have here this sensor with the device ID 122. If I'm now entering this two information, vendor ID 333 and device ID 122, then I have verified that on this port just the pressure sensor can be connected. We are making now a download. And we are going online. Then we see everything is running because the sensor has the right vendor ID and also the right device ID. We see here also on the board that the port here is activated now, means IO Link is running. And if I now make, for example, change, take here a VPPM. Here is my sensor. I'm disconnecting the sensor. And I'm now connecting the VPPM. Then you recognize nothing is running. because the VPPM has another vendor ID and also another device ID. That means the validation is working with the setting. Disconnecting the sensor of VPPM, connecting again our pressure sensor. Everything is running as expected. If we want now to change a parameter during operation, therefore we need first of all a library. Festo is offering in the support portal a library for the parameterization of API IO-Link devices. We go here now to the libraries and we open the library here, Open Global Library. I have downloaded it already from the support portal and it is located here on my desktop at Profinet API library. And the first thing what I have to change here, it is a compressed library, otherwise it is not appearing. And I'm opening it to find a folder where the file has been inside. And in my case, it exists already the folder, but I can overwrite everything. And then after a few seconds, I'm recognizing, okay, the library is for version 50.1 and higher. That means for me, because I'm using version 16, update 1, I have to upgrade the library. So now the library is here appearing on the right side of the global libraries. And you see here the function blocks which are available. And for this video, we are needing just the API IO-Link parameter function block. And we are adding this IO-Link parameter function block directly to our program blocks. Compile everything. And you see data type IO-Link no longer exists. We have 8 warnings. The reason why this is happening is because I need additionally for this function block the Siemens IO-Link device function block, because it is based on some functionalities of the IO-Link device function block of Siemens. Just drag and drop this also to my system and making again a compilation. And now everything is fine. To change now a parameter of an IO-Link device, we need the IO-Link index and the sub-index. For training's purpose or for this video, I'm now taking something called the black light color of the sensor. As you recognize here, the sensor has here a blue color, and I will change this blue color to a black light color of red, which would be here at index 136, sub-index 0, and the value of 1, for example. To do this, I'm taking the IO-Link parameter block here inside my system. And I have here now different possibilities to read and write IO-Link specific data of an index, sub-index. And you see here, I'm executing the block here with a rising edge. For example, I now just use a tag 1 here. Here I need the hardware identifier. This hardware identifier is available here on the API system. going to the port 1, going to the properties, going to the system constant, and then I'm seeing here for the port 1, I need the hardware identifier 273. Going back here, 273, the port is 1, and now the index and the subindex. I will make this index and subindex variable. That's the reason why I would like to use here now two variables, and therefore I'm adding here a new block, data block. I say here IO link data, and first of all I say here index is a usint, subindex is a usint, and now I can go here back and say here IO link data index. Going here IO link data subindex. The read write I'm doing again with a tag, and here the data length and the data self I'm defining also as variables in the data block. Means going back here to my IO link data, the length is a usint, and the data is for me, for example, an array of 10 bytes. So going here again back, IO link data, first of all the length, again IO link data, data none finished. Now I have defined the block for my needs, and now we are making a short test. So here you see now the block. He is not executed per default because here is the false, and he is only executed by a rising edge. Means if I'm changing from false to true, then the block will be executed. Here the read write functionality, with false I'm reading, with true I'm writing. Means for me I want to write a parameter, modify this to 1. Now the block is ready to write something. To have no errors, the block needs the index and the subindex. If we are going back to our manual, then we recognize, okay, it is 136. But this is a hex information, and the block works with unsigned integer. That means for me, going here to my calculator, hex 136 is decimal 310. First of all, I'm recognizing here, oh, okay, this is a different data format. That was a small mistake before. If I'm going here to my IO link parameters and go, I have to say here, this is not a unsigned short integer, it is a uint, unsigned integer. Just recognizing this before making here again a download. And now we go online again. And now everything is looking good for me. Okay, then we have to define the value, which was 310. The sub-index was 0. We want to write the data length. Going here again to the menu is, if I'm going up, 2 bytes. Okay, 2 bytes data length. Modify operand 2 bytes. And I want here now to change the data, means I'm going here to my system and say here this modify operand is 1 because I want to have the red display. And now I'm executing the block and I have an error. Modify to 0 and recognizing that there is a switch of the bytes. And now executing again. And the block is true. What I have right now done is we have to take care about the byte swap if we are using more than 1 byte of data length. That's the reason why I switched here to 0, 1 and here 0, 0. This you have to take care here in Siemens because there you have always a byte swap because they are using the Motorola format and IO-Link is Intel based. So we have done this. We are checking now the result on the sensor and we are recognizing we have changed the color with the function block. As you know, we have activated the backup and validation functionality. If I'm now taking here another sensor and connect this sensor, then we would expect that the sensor would be also red. And what you are recognizing now is, no, the sensor is not red. Because to activate the backup functionality inside the IO-Link master, it is a must to execute one time the save parameterization with a system command. To do this, we are changing this again to red, modify true. We are recognizing here it is red inside the master and in the device. And now we need the system command for the change of the backup functionality permanently. And this is here in index 2, sub-index 0, the command 5, what is mentioned inside the specification. Again, 02, sub-index 0, and parameter download store, finalize the parameterizations. We need a command 5. Going back to our block, means I modify here the operand to 2. I am changing here to 1. And I'm changing now here my command. This I don't need because we are now writing a byte to 5. And if I'm now executing it, modify to 0, modify to 1, I have activated the backup functionality on port 1 permanently. You see here now again the sensor. Disconnect the sensor, connect the other sensor, and recognizing it is working, it is automatically read because we have now used the backup functionality inside the device. That means for us, to sum up, first of all, we can change parameters during operation with the corresponding function block of festo. If we want to use the validation, we have to activate the parameter inside the IO link master. If we want to use the backup functionality, then we have to activate it also in the IO link master. But additionally, after changing the parameters, we have to execute one time the system command from the IO link specification that the master is creating a backup of the connected IO link device and the corresponding parameters what we have changed. Thanks for your attention and have a nice day.